Is heat. Heat is not what you think it is. Believe me, it's not. It's abbreviated with the symbol Q. All right. And it's measured in joules. Unit is joules. Okay. So heat, it's an energy, but it's kind of like that doesn't quite capture it. It's energy, but it's a transfer of energy. It's a flowing of energy. It's a movement of energy. Okay? So I'm going to define it as a movement of energy. That might seem weird to you, because it is weird. It's a weird way to define heat. We say something's hot, we usually mean it just has a high temperature. But if it's hot, it probably also moves energy pretty well. So by our physics definition, you say, yeah, it probably is hot. Heat is just the movement of energy. It's like a verb. It's like running. That's what it means. It's like running. This is if something if there is heat, then what we're saying is that there is energy that's exchanging. So energy is either being sucked in or given off. When energy is flowing into an object, if energy is flowing into like say a system right here, if energy flows into a system, our system of interest, we say it has positive heat. If energy flows out of a system, it has negative Q, negative heat. All right. So heat can be positive, heat can be negative. It's kind of like a vector in that sense. If you flow into something, if heat goes into something, let's say we're considering this little thing of water here, this little glass of water. If you inject energy into this, then we consider that to be positive Q. If energy comes out of this, it's negative Q. So heat comes out, it's negative. Heat goes in, it's positive. Got it? Okay. Now there's different ways to transfer this energy. There's different ways that heat moves. So ways of transferring. This is what is all over the internet. So ways of transferring energy or ways of heat. Ways of heating. Same thing. Ways of transferring energy. One way is through conduction. I'll use different colors for these. Conduction. Conduction is when heat is transferred through a direct contact. So you have one object contacting another. So direct contact. It can be a solid interacting with a solid. It can be a solid interacting with a liquid. It can be a liquid interacting with a liquid. Gases are a little bit weirder because gases are a whole bunch of tiny little objects, you would call them. So direct contact, and it's between solids and liquids. They're involved in this little scenario here of conduction. That's one way of transferring energy. Another way of transferring energy is something we call convection. Conduction, convection, these things sound similar, but they're very different. Convection is when heat's transferred through the motion of fluid. So you've got fluid that's being transferred here, and this is different than convection, the motion of fluid, because it's going through motion. It's through motion. Through the motion of fluid. And this can be solid. This can be, solids. I wonder if solids can move through this. I bet they do. Well, not so much. They don't really expand or contract. So I don't think they could. So mostly I think this would be just liquids and lots of gases. A way to think of this, let me give an example of this, and I'll give an example of conduction in a second. So convection would be something like an oven, where you have, I'm sure you've seen convection ovens. If you look inside of an oven, here's like a little oven rack, and let's say here's the turkey inside here. If you eat turkey, this is going to be a bad attempt at turkey. Oh my God, that was supposed to be a turkey. Okay, so you've got gas in here, and this gas is going to be not just staying still, it's actually going to be heated up from the coils down here. The gas is going to be heated up, and it's going to move, around this turkey. And as it moves around this turkey, it's going to disperse its heat to the turkey, and the turkey bakes that way. When it gets to the top, it's expanded as high as it can. It touches this cool surface at the top here, and it starts to condense, and it starts to flow back this way. And on both sides of here, you'll find this little current happening. It looks like a stream almost of hot air coming up and then rising and falling. And this is a convection current. You see this on the Earth too. This is why we have like jet streams and so forth. That's convection. Conduction's a little bit different. Conduction is when you have a direct contact with something hot. So let's say you have a hot pan on the stove. Here's your hot pan. And you decide, oh, I'm going to take off that hot pan from the hot stove. Let's say it's inside the oven. Again, oven example. It's in the oven. Here's the oven. And you go in and you say, oh, I'm going to touch that. That sounds like a good idea without any oven mitts. And I say, no, it's not a good idea, because when you touch that, you're in direct contact with something very hot, and that will then excite all the little atoms in your hand, and it's going to excite it to such a degree that your brain senses that as pain and says, ow! And it's going to say, retract your arm, take it away from this hot surface before you can even think about it. It's pretty cool how your brain can do that. Actually, your brain doesn't even involved with it. It's just your spinal cord. But you'll be taking back your hand without even knowing it because it's so hot. So that's conduction. This is convection. And the last one is radiation. I'll do that one really quick. Radiation. Radiation is when you transfer heat through space, or you can transfer it through space. That's what the sun does. It's transferred through electromagnetic waves, I'll just say EM waves. So it's transferred through electromagnetic waves. So, for example, the sun, that's an easy one. The sun heats us, and we don't even need the sun. Its energy does not go through. It doesn't pass through space. It doesn't need to have any. Well, it does pass through space. I'm sorry. Let me start again. It passes through space without having to use things like other media to try to transfer the heat. It goes right through empty blank space, and it can transfer its energy to us. It can warm us. It does this through these little electromagnetic waves. These little waves, they jiggle really, really, really fast, and they can go through space. And then when they hit something, they impart their energy on it. So that's how the sun does it. That's a little tricky compared to these, which we see in every day. But the sun, well, I guess we see that every day too, for the most part. But that's how it works. The sun is transferring you energy through these little EM waves, these little electromagnetic waves. Finally, the last thing I got to talk about before I go is the concept of thermal equilibrium. Thermal equilibrium is really to do with temperature. Let's say you have two objects. Here is a colder in relationship to this one. This one's a hotter object. Let's say you put them right next to each other. What happens? They go and they transfer. This one transfers its heat over here. So this one would have, we could say, oh, that one's a negative Q if you're considering this. And then from this perspective, from the blue perspective, you'd say, oh, that looks a positive. That looks like a positive Q to me. Oh, that's nice. That's a positive Q to me. The heat is transferred, but when the heat is transferred to the point at which this blue one, will then transfer heat back to this at the same rate, that is thermal equilibrium. And you can guess that their temperatures are going to be the same at that point. So I'm going to draw them with same color now. Oh, now they're just the same color. So that means that the heat that's transferred from this block over here will equal the same amount of heat that's transferred back. And it's probably not going to be as much heat as this was originally transferred. So this Q is the same both directions. So that is thermal equilibrium. It's when the rate of heat exchange is the same for both objects. And it happens when they're at the same temperature. That's it. Okay. Now some walkthrough warm-up problems. Oh, you can do this. I'm going to let you finish these. Okay. Have a good time with the problems. They're so simple once you understand these definitions, and I've given you some extra videos to understand those as well. So good luck. Bye.